Okay, good morning students. Welcome to today's lecture. So in our last lecture, we had started with the properties of fluid. Okay, so last time we had seen what is unit, what is dimension, and how to specify the dimension for any in that particular property. And A, B, and C are the coefficient. Okay, then we had started with the properties of fluid. So first property which we had seen was mass. Okay, so mass is nothing but quantitative measure of matter present in the substance. It is denoted by m. Its unit is kg and grams. Okay, and its dimension is m1 l0 t0. Then the next quantity which we had seen, that was mass density, which is mass per unit volume of the fluid. Okay, it is denoted by Greek symbol rho. So rho equals to mass upon volume. Okay, and its unit is kg per meter cube in SI and gram per centimeter cube in CGS system. And about its dimension is m1 l minus 3 t0. Okay, then remember the value of mass density for water, it is 1000 kg per meter cube, and for mercury it is 13,600 kg per meter cube. These values will be required for solving the problem. Okay, so remember these two values. Then next is specific weight. So it is weight per unit volume of the body, denoted by Greek symbol gamma. Unit is Newton per meter cube and dyne per centimeter cube. And dimension is m1 l minus 2 t minus 2. Okay, how these dimensions are derived, we had seen this in last lecture. Okay, then remember the value for water. So for water it is 9810 Newton per meter cube or 9.81 kilonewton per meter cube. Okay, then specific volume, it is volume per unit weight of the fluid, denoted by V suffix s. Okay, and this specific volume is nothing but it is inverse of mass density 1 upon rho. Its unit is meter cube per kg and dimension is m minus 1 l2, sorry, for यहाँ पे correction है, it is m minus 1 l3 t0. Okay, the next is specific gravity. It is the ratio of specific weight of the given fluid to the specific weight of standard fluid which is taken as water. Okay, so gamma, specific gravity S is gamma of fluid upon gamma of water. Okay, as it is a ratio of two similar quantities, so it is unit less and dimension less. Okay, and for water the specific gravity is 1. When we had seen, I think, these two problems, this type of problem can be asked in exam. Okay, so we had solved two problems in our last lecture. So in today's lecture, we are going to start with our next topic, that is viscosity of the fluid, or next property, which is viscosity of the given fluid. Okay, now what is viscosity? Okay, now viscosity is nothing but it is the property of the fluid by virtue of which the fluid offers resistance to deformation under the action of shear stress. Okay, we had already seen in our first lecture that if we consider any imaginary cube of solid, and if we are applying the shear force Fs, okay, so what will happen? This solid will have some deformation like this. Okay, shear deformation. And what will happen if you remove this force? If you remove this force, so this solid will regain its original shape and size. Okay, so this property is nothing but elastic property which is shown by solids. Okay, but instead of solid, if you are taking any imaginary mass of fluid in cubical shape like this, and you are applying the shear stress, so what will happen? This fluid will continuously deform. Okay, its deformation del L, it will be continuous or infinite. Okay, so it will have infinite deformation. Okay, so this is the case with liquid or gases, or we can say this is the case with fluid. So fluid is nothing but a substance which will have continuous deformation under the action of shear stress. Okay, that means if you take the case of water, suppose this is water. Okay, suppose this is a case of honey. Honey is also a fluid. Then you can take oil. Oil is also a fluid. Okay, and if you apply the shear stress, okay, if you apply the shear stress on this imaginary mass of water, honey and oil, so all these three, they should have continuous deformation. Okay, but have you observed the deformation is same in all the three cases? No. Okay. You can take a simple example. Take a glass of water, take a glass of honey, and take a glass of oil. Okay, and pour them simultaneously. You will observe water glass, it will get emptied quickly. Oil will take more time than water, and honey will take the maximum time. Okay, so although all these three are the fluids, but if you are applying the same acceleration due to gravity, okay, in downward direction, the flow pattern is different. Okay, that means there is some resistance. Okay, there is some resistance. This honey will going to offer more resistance to shear stress. Okay, water will going to offer less resistance, so water will flow quickly. Honey will offer more resistance. Okay, so it will flow slowly. And oil, it will have more resistance than water and less resistance than honey. Okay, so its velocity of flow will be more than water but less than honey. Okay, that means each fluid is offering some resistance to deformation. Okay, when shear stress is applied. Okay, so viscosity is nothing but this property. Okay, so viscosity is nothing but the property of the fluid. What is the definition? It is one of the property of the fluid. Okay, by virtue of which the fluid, it will going to offer the resistance to deformation. Okay, remember this is a key word. The viscosity is nothing but resistance to deformation. And when this deformation, it will happen when you are going to subject the fluid under the action of shear stress. Okay, so viscosity is nothing but resistance to deformation under the action of shear stress. Okay, so remember the definition for viscosity. Okay, and viscosity is also one of the property of fluid. Okay, so you can take this picture again. In this picture, this is a flow of oil, this is a flow of water, this is a flow of honey. Okay, all these three are flowing through the same pipe. Okay, of having same diameter and same elevation, but you can observe water is flowing quickly, oil is flowing at a lesser velocity, and honey is flowing more slowly. Okay, now, in order to understand in detail, again, this, we will see some videos on viscosity. Wait. Okay, so is my screen visible? Okay, so I'm playing the video. Okay, now you can see this simple example. In this example, there are two glass, one filled with water and other filled with glycerin. Okay, and we are going to drop a ball inside this one. Okay, so we can see in this example, they had dropped the two balls, one in water and second in glycerin. Okay, but you can observe here the water, the ball which is dropped in water, it is moving more quickly, and the ball drop in glycerin, it is moving slowly. Okay, now we will see one more video. Okay, now you can see this experiment. In this, the first can, it is filled with water, second is filled with solution, third is filled with glycerin, and fourth is filled with honey. Sorry, third is filled with oil. Okay, so what we had seen in this video, when we are dropping the different balls, okay, so you had observed the velocity with which the water was moving. Okay, it was different in each case. Okay, that means when you are dropping the water ball in water, it was flowing more quickly. Okay, when you are dropping the same ball in, suppose, honey or glycerin, so the ball was moving slowly. Okay, why this is happening place, why this is taking place? Because there is some property inside the fluid. Okay, there is some property inside the fluid which is offering the resistance to motion. Okay, in case of water the resistance was minimum, so water was flowing quickly. In honey, glycerin or other liquids, the resistance was more. Okay, because of that the ball was moving slowly. Okay, so this property of the fluid which offers this resistance to deformation under the action of shear stress, so this property is nothing but viscosity of that given fluid. Okay, so is this definition understood? Okay, now we are talking about or we will see the physics behind this definition of viscosity. Okay, so we had already discussed that some shear stress is applied. Okay, whenever any body or ball is moving inside the liquid, okay, there is some shear stress tau. Okay, there is some shear stress tau which is applied. Okay, so and this ball will be moving with velocity u. So what is the relationship between this shear stress and this velocity of fluid u? Okay, so the law which states the relationship between this viscosity, okay, this viscosity mu, the shear stress tau and velocity u, so that law is nothing but Newton's law of viscosity. Okay, so this Newton's law of viscosity states the shear stress is directly proportional to the rate of shear strength, okay, or velocity gradient. Now, in order to understand this, we will take one again the same case. Consider there are two parallel plates. Okay, consider there are two parallel plates. Suppose lower plate is fixed. Okay, so as the lower plate is fixed, its velocity u will be 0. Okay, and the upper plate u is moving, or upper plate is moving with velocity capital U meter per second. Okay, and let any imaginary fluid, okay, you can consider water or any ideal fluid, okay, it is filled inside or in between these two parallel plates. Okay, now you can divide this mass of fluid into number of layers. Okay, you can divide this into number of layers. Okay, like this, there are number of layers of fluid mass like this. Okay, now, as per the definition, when you will apply the shear stress, or when you will apply the force F on this cross section area or surface area A, so this force per unit surface area, okay, shear force per unit shear area or surface area, it is nothing but shear stress. Okay, so you are going to apply the shear stress tau on the upper plate. Okay, and because of this shear stress, this plate will going to move with velocity capital U meter per second. Okay, now what will happen? Now the layer of fluid in contact with this upper plate, okay, it will also move with velocity U meter capital U meter per second. Okay, similarly lower plate is stationary, so its velocity is 0. So the layer of the fluid in contact with this lower plate, its velocity is also 0 meter per second. Okay, that means the upper layer of the fluid, it will be moving with capital U meter per second, while the lower layer will be moving with velocity of 0 meter per second. Now what will happen in between all these layers? Okay, all the layer between upper layer and lower layer. Okay, so in between them, the layer above the lower layer, it will be moving with velocity more than 0 meter per second. Okay, उसके ऊपर का जो layer है उसका velocity उससे थोड़ा increase होगा. Okay, so step by step, layer by layer, the velocity will be increasing, and the velocity will be capital U meter per second at the top layer. Okay, that means this is the upper plate, this is a lower plate. Okay, so you can draw this velocity profile. Okay, so this is a velocity profile. Velocity will be 0 at the bottom, it will be capital U meter per second at the top. Okay, and in between them the velocity is slowly increasing like this. Okay, so is this understood what is happening when the flow of fluid is taking place between one fixed plate and other moving plate? Okay, now we will talk about any layer like this. Okay, we will talk about any layer of the fluid like this. Suppose this is any layer, this is our lower plate and this is our upper plate. The lower plate is fixed and upper layer is moving with velocity capital U per meter per second. Okay, so on this lower layer the velocity on the bottom side will be small u meter per second, while the velocity on upside of this layer will be u plus du. Okay, we had just seen the velocity is increasing, so for this distance dy, okay, suppose this height of this layer is dy and this layer is situated at a distance y from bottom plate. Okay, so at distance y velocity is u, at distance y plus dy the velocity will be u plus du. Okay, so basically for this distance dy, okay, for this distance dy there is a change in velocity du. Okay, so this ratio of change in velocity per unit change in distance, this is called as velocity gradient. Okay, this is nothing but velocity gradient or the rate of shear strength. Okay, so this change in velocity per unit change in distance, this is called as rate of shear strength or velocity gradient. So as per our Newton's law of viscosity, the shear stress applied is directly proportional to this rate of shear strength or velocity gradient. Okay, so is this understood what is Newton's law of viscosity? Okay, so we will see the derivation. Okay, so consider any imaginary mass of fluid moving like this. Okay, let the lower plate is stationary. Okay, so this is fixed, so velocity u equals to 0. Now as the distance increases in y direction, the velocity u of the fluid is also increasing in y direction. Okay, now consider any imaginary layer of fluid. Okay, consider the lower layer or lower side of this layer, it is at a distance y and its velocity is u meter per second. Okay, then for a distance y plus dy, okay, for this distance y plus dy, y plus dy, the velocity will be u plus du. Okay, that means for this change in distance dy, the change in velocity is du. Okay, so this ratio of du by dy, which is called as velocity gradient or rate of shear strength. Okay, so that is proportional to the applied shear stress. Okay, so as per the Newton's law of viscosity, the shear stress is directly proportional to the shear rate of shear strength or velocity gradient of the fluid. Okay, so tau is directly proportional to du by dy. Okay, then now we already know this is a symbol of direct proportionality. So in order to remove this, okay, we had to introduce some constant. Okay, so that constant is nothing but that constant is denoted by mu. Okay, so the constant which specify the relationship between shear stress and velocity gradient, that is denoted by mu, and it is called as viscosity of the fluid. Okay, so this mu is called as absolute viscosity. Okay, absolute ABSO, absolute viscosity or dynamic viscosity. Okay, it is called as absolute viscosity or dynamic viscosity or simply viscosity of the fluid. Okay, so this mu is called as absolute viscosity or dynamic viscosity or simply viscosity of the fluid. Okay, so tau equals to mu du by dy. So this is a mathematical relation which any fluid follows as per the Newton's law of viscosity. Okay, here mu is nothing but this Greek symbol mu. This is called as mu. So mu is nothing but constant of proportionality and is called as coefficient of dynamic viscosity or simply dynamic viscosity, or in simple word it is viscosity of the fluid. Okay, and du by dy, it represents the rate of shear strength or rate of shear deformation or simply velocity gradient. Okay. So any doubt about Newton's law of viscosity? Shall I repeat? Or is this understood? See, fluid mechanics में आप जो भी learn कर रहे हो, all these are new concept. Okay? So आपको fluid mechanics first time थोड़ा difficult लगेगा, but when you are going to read this at home by your own, okay? So fluid mechanics is a simple subject. Okay? सिर्फ इतना था कि सॉम में और अदर सब्जेक्ट में थर्मोडायनेमिक्स में आपको गैस लॉस और टाइप ऑफ स्ट्रेसेस ये ऑलरेडी आपको 9-10 से पता थे, बट न्यूटन्स लॉ ऑफ विस्कोसिटी ऑल दिस न्यू डेफिनेशन, मास डेंसिटी, ये ऑल सारी डेफिनेशन फर्स्ट टाइम आ रही है. ओके, सो फ्लूइड मैकेनिक्स पे आपको थोड़ा ज्यादा कंसंट्रेट करना पड़ेगा आपके बेसिक क्लियर रखने के लिए. ओके, एंड रिमेंबर फ्लूइड मैकेनिक्स इज अ बेस ऑफ हाफ ऑफ द मैकेनिकल इंजीनियरिंग. फ्लूइड मैकेनिक्स का सारा नॉलेज आपको है तो आपको आगे सब्जेक्ट सिंपल पढ़ेंगे. ओके, then we will see what is the unit of absolute viscosity and what is the dimension of absolute viscosity. Okay, so first of all we will define the unit. So we know mathematically tau equals to mu du by dy, or shear stress equals to absolute viscosity into velocity gradient. Okay, now we can rearrange this as mu equals to tau upon du by dy. Okay, so you can specify the another definition of absolute viscosity. So absolute viscosity is nothing but shear stress applied on the fluid per unit velocity gradient. Okay, so when velocity gradient equals to 1, okay, then mu equals to tau. So another definition is it is shear stress per unit velocity gradient applied on the fluid. Okay, so we can say this mu, absolute viscosity mu, equals to shear stress upon du. What is du? Change in velocity. And what is dy? Change in distance. Okay, so we can simplify this. So mu equals to shear stress. Now what is shear stress? It is force upon surface area, okay, divided by velocity. What is velocity? It is change in length per unit time. And what is distance? It is nothing but 1 upon length. Okay, 1 upon distance is 1 upon length. Okay, now here what will happen? This length will cancel with each other. Okay, this length and this length will cancel with each other. This time, 1 upon time, it will go in numerator, so it will be force into length square. Okay, now this area is nothing but product of b into h. Okay, so b is again length and h is again length. Okay, breadth into height. So it is 1 upon length square. So force upon length square upon time. Okay, so we can say it is force into length upon force into time upon length square. Okay, so the SI unit will be the unit of force. The unit of force is Newton, into time is second, upon length square is meter square. Okay, so the unit of absolute viscosity is Newton second per meter square. Okay, so in SI system, the unit of absolute viscosity or simply viscosity is Newton second per meter square. Okay, in CGS system, the unit of force is dyne. Okay, so it is dyne second per centimeter square. Okay, so in CGS system, the unit of area is centimeter square. So it is dyne second per centimeter square. Okay, so remember, always remember the unit. The unit of force is, the unit of absolute viscosity is Newton meter per second square, and the unit of absolute viscosity in CGS system is dyne second per centimeter square. Okay, after that, next is our dimension. Okay, yeah, again, see, these are the standard unit, but in addition to that, okay, there are some industrial units. Okay, that means आप इंडस्ट्री में जाओगे when you will go in industry और आपको कोई oil select करना है, so basically oil का viscosity वहाँ पे poise में define रहेगा. Okay, it is 100 poise, 200 poise. Okay, so remember the relationship between poise and CGS unit. So poise, one poise is nothing but it equals to 1 dyne centimeter square, dyne second per centimeter square. Okay, that means this 1 dyne second per centimeter square, this is nothing but equal to 1 poise. Okay, now what will be the conversion for Newton second per meter square? Okay, so remember 1 Newton second per meter square equals to 10 poise, or 1 poise is equal to 1 by 10 Newton second per meter square. Okay, so 1 poise is 1 dyne second per centimeter square, or 1 poise is nothing but 1 poise equals to 1 by 10 Newton second per centimeter, Newton second per meter square. Okay, so ये दो conversion आपको याद रखने हैं. Okay, for solving the problem. Okay, because प्रॉब्लम में आपको जो विस्कोसिटी दिया जाता है वो पॉइस के फॉर्म में दिया जाता है, बट आपको फर्स्ट ऑफ ऑल 1 पॉइस को 1 न्यूटन सेकेंड पर मीटर स्क्वायर में कन्वर्ट करना है बाय डिवाइडिंग विथ 10. ओके, एंड देन you can solve the problem. Okay, so remember this conversion is important from problem point of view. Okay, after that next is dimensions of viscosity. Okay, now we had just seen mu is nothing but force into time divided by length square. Okay, so it is the dimension of absolute viscosity mu is nothing but dimension of force into dimension of time upon dimension of length square. Now how to remember the dimension of force? Okay, remember dimension of force. Force is nothing but mass into acceleration. Mass, so I'm taking the dimension of mass into dimension of acceleration. Okay, now what is the unit of mass? Kg. So it is m1. And what is the unit of acceleration? It is meter per second square. So it is L1 meter per second square. So it will be t minus 2. Okay, so always remember the dimension of force because it will be required for calculating the other dimension. Okay, so dimension of force is m1 L1 t minus 2 into dimension of time. It will be m0 L0 t1 divided by dimension of length square. So it will be m0 L1, but square होने के कारण वो square अंदर आ जाएगा, so it will be L2. Okay, so L2 into t0. Okay, now here we will write, so it will be m to the power 1. ये 0 है multiplication में, so you can add here plus 0, और ये क्या है denominator में, so you can minus 0. Okay, so we will have m1. Okay, then about the length. Okay, so here the power is to the power 1, here is 0, so plus 0. Okay, and here is 2, but when it will go in numerator it will become minus 2, so it will be plus 1 minus 2. Okay, so it will be m to the power 1 L to the power minus 1. Then about the time, so it is t to the power minus 2, then here minus 2, then here plus 1 and minus 0. Okay, so minus 2 plus 1, so here t to the power minus 1. So the dimensions are m to the power 1 L to the power minus 1 t to the power minus 1. Okay, remember this dimension they are going to require in unit number 6. Unit number 6 आपका पूरा की पूरा dimension के ऊपर है क्योंकि उसका नाम ही है dimensional analysis. Okay, so here you are in that unit आपको सारे dimension, सारे properties के dimension आपको पता होने चाहिए. Okay, then second thing, again in viva or even in exam, okay, this dimension can be asked for derivation. Okay, find out the dimension of absolute viscosity, find out the dimension of surface tension, and so on. This type of question can be asked. Okay, so remember the process, how to calculate the dimension of any given property. Okay? Then effect of temperature on viscosity of the fluid. Okay, Now, have you observed when basically the girls will understand it more quickly that when you're cooking, okay, have you observed the viscosity of oil? At room temperature, the oil is very viscous. But when you start heating the oil, what will happen? That oil will going to behave like water. Okay, जब आप उसको 80 डिग्री 90 डिग्री पे कर देते हो, so drop one spoon and see. Okay, उसका viscosity जो है, that viscosity will become almost equal to that of water. Okay, that means what is happening when you are heating the oil, its viscosity is reducing. Okay, that means there is some effect of temperature on viscosity of the fluid. Okay, so now we are going to discuss what is the effect of temperature on the viscosity of liquid and what is the effect of temperature on the viscosity of gases. Okay, now what happens in case of solid? In case of solid, okay, the crystal structure is there. Okay, so each atom is having its own location. Okay, so solids are well defined crystalline structure. While in case of liquids, okay, in liquids the molecules can move here and there. Okay, all the molecules can move here and there, but these molecules are held together. Okay, these molecules are held together by stronger cohesive forces. Okay, so because of that, the molecules of same liquid, they will be always closely packed. Okay, because the cohesive forces are stronger as compared to adhesive force between liquid and gases. Okay, so because of that, these molecules are close to each other. But what happens when when you supply the external heat? Okay, so when you supply the external heat, what happens? These molecules which are close to each other, so their center to center distance is small. Okay, and as the center to center distance is small, there is more cohesive forces. Okay, but when you supply the heat, the thermal expansion of this molecule take place. Okay, this thermal expansion of the molecule take place, and as the thermal expansion take place, okay, there center to center distance it will increase. Okay, so as the center to center distance increases, these cohesive forces become weaker. Okay, so these cohesive forces will become weaker, and basically in case of liquid, the viscosity is due to cohesive forces, and as the cohesive forces reduces, the viscosity of liquid reduces with increase in temperature. Okay, so as you supply the heat to any given fluid, its temperature will rise, and as the temperature will rise, the cohesive forces or molecule attraction, it will reduce due to thermal expansion of the molecules, and because of that, the viscosity of that given fluid, it will reduce. Okay, so remember this. So in case of liquid, the viscosity of the given fluid decreases with increase in temperature. Okay, so this is a case with liquid, but same will not going to happen with gases. Okay, remember in case of gases, okay, in case of gases, okay, consider a closed container. These are the gaseous molecules. Okay, now in case of gases, already the gases are not held together by cohesive forces. Okay, because of that, this gaseous molecule will continuously move here and there. Okay, so when these gaseous molecules are moving, they are continuously colliding with each other. Okay, हर gas molecule दूसरे gas molecule के साथ collision करते रहता है. Continuously this collision is taking place. Okay, and when this collision is taking place, some kinetic energy of this molecule, suppose this molecule is moving with more velocity, this molecule is moving with lesser velocity. Okay, so this molecule will collide here, so it will transfer its kinetic energy to this molecule. Its velocity will decrease, its velocity will increase. Okay, so there is some exchange of energy which is always taking place between the molecules, so that is called as molecular momentum exchange. Okay, and in case of gases, more the collision is taking place. Okay, more is the viscosity of the fluid. Okay, गैस का एग्जांपल कंसीडर करने के लिए we can take the example of ST bus. Okay, suppose HT bus है, HT bus में 50 or 10 passengers are traveling. Okay, all these 10 passenger they are standing. Okay, this is passenger 1, passenger 2, passenger 3. Okay, so now if one passenger want to hold the pipe, okay, so it will be easy from him to take the hand and hold the pipe. Okay, but consider the second case. In second case there are 100 of passenger. Okay, there are 100 of passenger. So ये पैसेंजर के पास इतना स्पेस ही नहीं है, ओके, कि वो अपना हैंड इजीली मूव कर सकता है ना. ये पैसेंजर को सपोज पाइप होल्ड करना है, so उसको बहुत ज्यादा फोर्स अप्लाई करना पड़ेगा. ओके, बिकॉज जब उसको हैंड मूव करना है तो बेसिकली सराउंडिंग के जो 20 पैसेंजर है वो उसके ऊपर कुछ प्रेशर एक्सर्ट कर रहे हैं. ओके, सो सेम इज द केस in case of gases. Okay, जितना ज्यादा मॉलिक्यूलर मोमेंटम एक्सचेंज रहेगा उतने ज्यादा कोलिजन्स होंगे, और जितना ज्यादा कोलिजन्स होगा तो एक मॉलिक्यूल को मूव करने के लिए उतना ज्यादा फोर्स अप्लाई करना पड़ेगा. ओके, सो more the molecular momentum, more is the resistance offered by the surrounding to the molecule to move, and that resistance is nothing but viscosity of that gas. Okay, so in case of gases the viscosity is due to molecular momentum exchange. Okay, is this understood? Okay, now what happens when you supply the heat, when you supply the external heat to these molecules? Okay, so these molecules will absorb this heat and they will be excited. Okay, ये जो heat supply किया ये molecules क्या करेंगे, absorb करेंगे, and that will going to increase its internal energy, and now they will going to move with more kinetic energy. Okay, so as the viscosity will increase, okay, the viscosity of gas will the temperature of the gas will increase, these molecules are going to move more easily. Okay, because अभी उनका internal energy बढ़ गया है. पहले क्या था, जब internal energy कम था तो उसको move करने के लिए ज्यादा resistance था, but अभी उसका internal energy बढ़ गया है तो automatically बाहर का जो resistance है वो इतना ही है और internal energy बढ़ गया है, so resistance धीरे क्या हो जाएगा, कम हो जाएगा. Okay, now as the internal energy will increase, this molecule will be able to move more quickly. Okay, और वो जितना ज्यादा मूव करेगा इजीली उतना ज्यादा उसका विस्कोसिटी डिक्रीज होगा. Okay, so in case of gases the viscosity of the gases will, sorry, vice versa. Okay, sorry, उल्टा हो गया. Now in case of gases, as the temperature will increase, okay, momentum, molecular momentum will increase. Molecular momentum के कारण क्या होगा, अभी ज्यादा number of collisions होंगे, all the molecules will be excited. Okay, ये molecule जितना ज्यादा मूव करना चाहेंगे दूसरे molecule से उतना ज्यादा टकराएंगे, और जितना ज्यादा टकराएंगे उतनी एनर्जी एक दूसरे को ट्रांसफर करते रहेंगे. Okay, so because of that the viscosity of the gas will increase. Okay, because higher temperature पे क्या होगा, molecular momentum exchange increase होगा. जैसे temperature increase होगा gases will excited, gases molecule will excited, and because of that their molecular momentum exchange will increase. Okay, and as the molecular momentum exchange will increase the viscosity will increase. Okay, so in case of liquid the viscosity mu decreases with increase in temperature, and in case of gases the viscosity mu will increase with increase in temperature. Okay, so that is also shown by this graph. Okay, as the temperature is increasing, as the temperature is increasing, viscosity of gases are increasing. Okay, while the viscosity of liquid it is decreasing. Okay, so today we will stop here.